Alright, this is Honors Algebra 2 Pre-Calc. This is 9.6 in Pre-Calculus, and we're going to talk a little bit about the difference between combinations and permutations. So, both of these concepts are going to matter when we talk about counting principles, but when we talk about having a certain number of items, right? So frequently you talk about having n items, right? And then we talk about picking or choosing r of those items, right? So, for example, if you had all 26 letters and you were going to pick 3 of them, well, there's 2 different ways to pick those things. You could pick 3 letters out of the 26 where order doesn't matter, where ABC and BAC are the same. I just need to know what 3 letters. It's not a ranking. It's just, hey, I need 3 of these letters. But you could also pick 3 letters out of the 26 letters where the order does matter, where the first letter you pick matters compared to the second, compared to the third, right? So one of these is called a combination. So combinations are what we use when order doesn't matter. So where ABC is the same as BAC. And that's that NCR that we've seen previously, right? That we saw in 9.5 when we did binomial expansion. So NCR, or n choose r, is that n factorial over n minus r quantity factorial times r factorial. In a word problem, the hint that you're going to be using combinations is usually that you see words that talk about committees or groups or flat out say that order does not matter, right? So if the principal calls my classroom and says, Hogan, I need 3 students to help me in the office, I could pick any 3 students. It doesn't matter if I give him Johnny's name, followed by Susie's name, followed by Bobby's name. It doesn't matter. I don't teach anyone with those names. Anyway, it doesn't matter who I say first. The 3 of them are going to go down to the office and have the same job helping the principal, right? But if instead I'm called and I'm asked, hey, who are the top 3 students in your class in order? Like, who's the number 1 student, number 2, and number 3? Well, then the order in which I say the names would matter, right? So that's an example of a permutation. So as we move forward, again, combinations are NCR, right? Like n choose r. And that's that n factorial over the quantity n minus r factorial times an r factorial. The difference between these 2 formulae is this r factorial, right? NPR, which I always say in my brain is n pick r, like I have 26 letters, I pick 3, but realistically the P stands for permutation and the C stands for combination. NPR is n factorial over n minus r quantity factorial. It's just missing this r factorial. So again, the difference, and you can kind of figure out the logic of why that's true, because essentially, you're dividing by the number of redundant answers here if the order doesn't matter. So if ABC and BAC are the same answer, then what's happening is when I divide by that r factorial, I'm essentially getting rid of all of those redundant answers because there will be a lot of them, right? ABC is the same as BAC, which is the same as ACB, which is the same as CAB. They're all the same answer. So I'm dividing by those redundant answers when I divide by that. It means that the number of combinations is always smaller than the number of permutations, because again, in combinations, ABC and BAC are the same answer, but in permutations, they would be different, because ABC means that A is the best and B is second and C is third, and BAC means that B is the best and A is second and C is third. When you're looking at problems that usually involve permutations, you'll see words like first, second, third, something that ranks, right? So you'll see ordinals, right? Ordinals are numbers that rank. So like, a cardinal number is 1, the ordinal number is first, right? Because cardinal just means it is a number, ordinal means you're ranking things in order. You'll also see things like vice president and president. So the question might say, how many different ways can you pick a vice president and president out of a student body of 20 people? Well, that's where order matters, because vice president is not the same as president, and so it matters which person you assign to which job. So that's kind of the idea. We're going to do some problems moving forward, but I wanted to lay out the difference between combinations and permutations now. Let's go ahead and actually walk through one example while we're here. So we're going to go ahead and walk through an example 4. So in example 4, you have 5 books. How many ways can you arrange 3 on your shelf? So here, because we're talking about an arrangement, now that's not a word I mentioned when we talked about permutations before, but because I'm talking about arranging books, you can imagine that if you were setting up your bookshelf and trying to make it look nice, the order you put your books in is different. So what this is going to be is this is going to be a 5p3, right? So if you were going to do it by hand, that's a 5 factorial over a 5 minus 3 quantity factorial. So by hand, that's a 5 times a 4 times a 3 times a 2 times a 1 over a 2 factorial, which is 2 times 1. these guys are going to cancel, and I'm going to end up getting that there are 60 ways to arrange those 3 books, right? Now, if I didn't care about which books, right, if instead I had asked this, so instead, if I said, how many ways to choose 3 to keep, right? Like, we're not saying it doesn't matter what order you choose them in. It's just, hey, how many different ways could you choose 3 of the 5? Well, then that would be 5 choose 3, right? Which would be 5 factorial over a 5 minus 3 factorial times a 3 factorial, right? Now, we already figured out that that's a 60, and it would be divided by 3 factorial, but we can walk through it if you want. So 5 times 4 times 3 times 2 times 1 over, this is a 2 times 1 times a 3 times 2 times 1. These guys cancel, and I end up with a 20 over 2, which is 10 ways. So if I just wanted to know how many ways I could choose any 3 of those books, there would be 10 ways. But if I now care about the different ways I order those books, there are 60 ways. So that's kind of the gist of how this works.